Welcome to The Explainer. I am so thrilled to have you here today because we're looking at one of the absolute most fundamental tensions of human existence. On one hand, we've got a rapidly growing global population that desperately needs to be fed. But on the other hand, well, the very methods we're using to feed everyone are systematically degrading the earth we actually live on. It is a massive, high-stakes balancing act.
And that brings us to the core of today's exploration. I want you to hold this question in the back of your mind as we go through this. What if the key to our agricultural future, the actual solution to this modern crisis, is 3,500 years old? Today, we're going on a fascinating journey where ancient wisdom meets cutting-edge ecological science. Section 1, the chemical fertilizer paradox. Let's kick things off on the modern side of the equation. We really can't have a genuine conversation about agriculture without acknowledging the incredible, entirely indispensable role of modern chemistry. I mean, without it, we'd be facing a very different, much hungrier world. Just think about this number, 190 million tons. That is the estimated global agricultural use of inorganic fertilizers in 2023. These synthetic nutrients are an absolute cornerstone of contemporary food systems. In fact, chemical fertilizers account for roughly 40 to 60% of global cereal production today. They are literally averting widespread global famine and sparing millions of acres of wildland from being converted into farmland.
Okay, let's dive right into this paradox. We absolutely need these inputs to survive, but our usage is highly inefficient. We applied so much fertilizer globally in 2023 that we ended up with a staggering 85 million tons of nitrogen surplus. That means 85 million tons were applied to fields, but were never actually taken up by the crops. And instead of growing our food, that massive surplus becomes a mobile pollutant, creating intense hotspots of environmental damage.
Section 2, the nitrogen cascade effect. So what exactly happens to all that leftover nitrogen we just talked about? Well, scientists call this the nitrogen cascade. And this brilliantly illustrates the sheer scale of our impact on the planet. The industrial Haber-Bosch process, which synthesizes ammonia for fertilizers, essentially mimics nature's lightning on a colossal scale. But we've done it so intensely that human activity now creates at least twice as much reactive nitrogen as all natural terrestrial sources combined. We've completely overwhelmed the natural nitrogen cycle, meaning a single atom of unabsorbed, human-made reactive nitrogen can trigger a devastating chain reaction across our air, our land, and our water.
And the crucial point here is that this cascade isn't just an abstract theory, it has very real, very dangerous fallouts. When it washes into our waterways, it triggers eutrophication, feeding massive algal blooms that literally suffocate aquatic life and create vast dead zones like the one in the Gulf of Mexico. When it leaches into groundwater, it can cause methomelagelemia or blue baby syndrome, which is a dangerous condition for infants. And when it vaporizes into the atmosphere, it often becomes nitrous oxide, a greenhouse gas that is roughly 300 times more potent than carbon dioxide at trapping heat.
Section 3, beneath the surface, soil health. Now, the damage from this cascade isn't just happening out in our oceans and up in the atmosphere. We really need to shift our focus down to the microscopic level of the soil itself. You see, soil is a living ecosystem, and chronic overuse of synthetic fertilizers is radically altering its chemistry. A comprehensive study of Chinese croplands over 4 decades revealed that long-term application of nitrogen fertilizers reduced soil pH by an average of 15.27%. That is a massive spike in soil acidity. And when soil becomes that acidic, it actually leaches out essential base cations like calcium and magnesium, while simultaneously mobilizing toxic elements like aluminum, which directly stunts plant roots.
What's really fascinating and kind of scary about this chemical shift is how it actively destroys the soil food web. Just look at these numbers. Mycorrhizal fungi, which help plants access water and phosphorus, plummet by 60 to 80%. Earthworms, absolutely crucial for water infiltration, drop by 50 to 90%. Total microbial biomass is reduced by up to 60%. Our synthetic dependency is actively disrupting the delicate symbiotic relationships that naturally keep soil healthy and resilient. Basically, we're treating the soil like an inert sponge rather than a living ecosystem.
Section 4, Vriksha Ayurveda, ancient farming wisdom.
So this brings us to a pretty critical crossroads. How on earth do we rebuild this living ecosystem while still feeding the world? Here we can trace a fascinating chronological arc. Around 1500 BCE, during the Vedic period in India, traditional ecological knowledge known as Vriksha Ayurveda, literally the science of plant life, guided a highly systematic organic approach to farming. Fast forward to the 20th century, the Green Revolution and industrial chemistry completely took over. But today, the future of sustainable agriculture, particularly a framework called regenerative organic agriculture, is actively integrating these exact 3,500-year-old practices to heal the damage of the last century. Two of the absolute most prominent bioformulations from Vrikshayurveda are Kunapajala and Panchgavya. Kunapajala is a fermented liquid manure made over 30 days using animal waste, cow urine, black gram flour, and jaggery. Panchgavya is derived from 5 cow products: dung, urine, milk, curd, and ghee, fermented over 15 days. These aren't just quaint old recipes. They are incredibly rich sources of macro and micronutrients, absolutely packed with beneficial microbes and natural growth-promoting phytohormones. Section 5. Testing traditional bioformulations. But of course, we can't just rely on ancient texts, right? We need data. We need modern scientific validation, like the recent rigorous field experiments done in Himachal Pradesh, India. To see how this builds into an applied science, let's quickly look at the prep. For Panchgavya, you mix fresh cow dung and ghee, then later add the urine, milk, curd, jaggery, and even banana. You let it undergo a natural aerobic fermentation in the shade for 15 days. The result is a biologically active liquid that you dilute and use as a foliar spray or a soil drench. It's essentially a high-powered, natural probiotic for the earth. And the results of testing this out in the field are absolutely staggering. Soil organic carbon is basically the master indicator of soil health. The control plot sat at 0.61%, but the plot treated with a combination of Kunapajala and Panchgavya achieved a soil organic carbon level of 0.92%. That is a massive 50.8% increase. This proves that Vrikshayurveda isn't just folklore. It is hard, verifiable science capable of rapidly restoring soil organic matter. And it didn't stop at carbon either. The combined bioformulations nearly doubled the microbial population in the soil compared to the control. Available nitrogen jumped by over 25%, and crucial enzymatic activities like dehydrogenase and phosphatase, which actually power nutrient cycling, they surged. Instead of degrading the soil, these traditional inputs act synergistically to completely restore the soil's self-sustaining fertility. Section 6. A regenerative agricultural future. So what happens when we take these highly effective ancient bioformulations and combine them with modern ecological science on a global scale? Well, we arrive at regenerative organic agriculture, or ROA. As modern research confirms, ROA goes far beyond just skipping synthetic chemicals. It's a holistic framework that actively rebuilds soil health, enhances biodiversity, and reestablishes natural nutrient cycles. It treats the farm not as an extractive factory, but as a living, breathing ecosystem. And the global implications of the shift are just massive. If we look at just one single aspect of ROA, cover cropping, studies show it has the potential to sequester 0.03 petagrams of carbon per year globally. That alone could offset approximately 8% of all anthropogenic greenhouse gas emissions. By healing the soil, we're literally pulling the excess carbon out of the atmosphere and putting it right back into the ground where it belongs. I want to share this quote from the research because it perfectly captures the core takeaway of this entire explainer. It reads, "A systemic transformation of agricultural systems is required, one that treats farms as living ecosystems, prioritizes soil health, and balances the undeniable need for productivity with the long-term imperative of ecological sustainability. We don't have to choose between feeding people and saving the planet. We just have to change our methods." Which leaves us with this final vital question. Are we going to keep mining our soil's organic capital for short-term gains? Or are we finally ready to look to the wisdom of the past to rebuild our agricultural resilience for the future? The science is incredibly clear, the methods are proven, and the choice is entirely ours. Thank you so much for learning with me today. Keep questioning, keep exploring, and I'll see you in the next explainer.